Shrikant, now it is 11 a.m.
Yes, sir, absolutely. We can
Uh,
start.
Now, most humbly, I would request to Honorable Director, sir. Sir, can we start the program now? Sir, waiting for your permission.
Please, Dr. Khadim, kindly go ahead.
Okay, thank you so much, sir. Now, Anchor, it is over to you. Now you can start the program, please.
Thank you so much, sir. Good morning to one and all. I'm Syed, second year electrical engineering student from BBDITM Lucknow. I request all the participants to keep your cameras and microphones shut until you have something urgent to ask. And don't create any kind of nuisance or you will be barred from the meeting. Our IEEE Student Branch team is a closely knit assembly of curious, optimistic, and hardworking individuals, striving to rise the bar of our college and establish its mark on the map. And we have been conducting many webinars and meetings to do so. Now, I would like to invite our Honorable Director, Professor Dr. Bhavesh Kumar Chauhan, for the welcome address. Sir, please.
I, on behalf of our chairperson, Srimati Alka Das ma'am, and President of BBD Educational Group, Mr. Viras Sagar Das, and on behalf of the IEEE Forum of BBD IITM, as well as UP section and India Council, and particularly the BBD IITM student branch, and more special V Affinity Group. I feel honored to welcome a very dear colleague and exceptionally courageous and hardworking, a man determined to make an impact with his work and noble intentions, Dr. Vivek Kumar Singh. Dr. Vivek, sir, your warmth and your eagerness to help those who are around you is really highly appreciable, and we feel a sense of gratitude towards you. And I'm sure the kind of research that you have been undertaking with the Ultrasound Research Center with Harvard University, that will be a motivating source to our students. So I really thank you from the bottom of my heart as well as officially, and we are looking forward for these sessions. Over to the anchor.
Thank you so much, sir. Our honorable speaker for today's expert talk is Dr. Vivek Kumar Singh. Dr. Vivek Kumar Singh is currently a research fellow in radiology with Massachusetts General Hospital, which is affiliated to Harvard Medical School, Boston, USA. Received a degree in computer engineering from Rovira I. Virgili University, Spain in 2019. Moreover, he received a master's degree in signal processing from the Sam Higginbotham Institute of Engineering, Technology and Sciences from India, and a bachelor's degree in electronics and communication engineering from Gautam Buddha Technical University, Lucknow, India, in 2014 and in 2011, respectively. He published more than 15 international research articles in collaboration with Rovira I. Virgili University, Spain, University of Bourgogne, French, University of Aswan, Egypt, and Bioinformatics Institute, Singapore. His research interests include computer vision, medical image processing, machine learning, deep learning, and signal processing. Now, I humbly request our honorable speaker to please to give his expert talk. Sir, please, the stage is all yours.
Thank you very much. So I'm going to share my screen first. Here is fine.
Yes, sir, perfectly.
Okay, thank you very much. Yeah, so first of all, thank you very much for director sir, and also the organizing committee for making this event fruitful for everyone. And also I would like to congratulate all of the students, those who are here and just going to take this lecture as informative information that could be useful in a future perspective. And so for today, actually, the presentation, actually, what we're going to discuss is actually based on the AIs and is a new height for AI in medical imaging. And also we will discuss what are the challenges when we are going to translate AI models to the AI model to the medical imaging part, and what are the opportunities in the future, what could find. And specifically what we observed, if we remember like our past years, like we compare from the past year, from the, if we go back 5 to 8, 10 years before, and then now if you compare in every field, like all of us, we realize there are some changes in the technologies. If you are seeing just from the cell phones, from the laptops, even for the some kind of your television, daily day-to-day life, we observe like some of the technologies is changing day by day, and most of the technologies now is adopting the AI technologies. So here in this presentation, in this lecture, we are going to cover some of the basic fundamental of the AIs. What is the AI? Some of the ideas about the AIs, some real application, and then we will move little bit narrows to the medical imaging part, and what are the different application, what are the different projects we could do, we can make it, and what are the some future perspective if we want to make our career, we want to target our career for the medical imaging part with using AI with the deep learning. So this is like a disclaimer, because I took some of the information from the internet resources, and any of them is not correctly cited. So if anyone has this article or some of the images or the content, please let me know. Yeah, so for today, this is agenda, in this presentation, including 1 hour presentation. So before going to start, I would like to mention, if anyone has any question, please feel free to ask me at the same moment. Don't wait for the end. And because we want with this this presentation, this conversation should be interactive from the both sides. So if you have any question from the small question, or if you have any technical more question, feel free to ask me. And so for agenda, we are going to get introduced about AI. And also there's some content of the AI, what is machine learning. Maybe some of them is familiar with the machine learning, maybe during their coursework. And recently new scenarios the deep learning is going through, and how deep learning is play a key role in the imaging part. Imaging means the images, or could be the videos as well. And what are the real application, because in our surrounding we are seeing lots of application, as I mentioned earlier. So there could be lots of application in a real life. So we are going to cover this part in the first section. The second part will be based on the completely is on the medical imaging. So because this is a very important part, because we need to we need to know what is a medical imaging, and how we can use the medical imaging, means how we can use the medical images to predict or to build some automated system for the doctors, for the clinician in the hospital, that can help them. And also, as we maybe some of them, we all we realize that some of the modalities, some like we have some difficulties, some of the challenges. We went to doctor and they just took X-ray or some of the abdomen ultrasound or MRI. So these are some imaging modality we are going to discuss later. And also, apart from this, we are going to discuss what are the real application of the AI in medical imaging part, and also as well as like some challenges and opportunities, as I mentioned earlier. And we will discuss like in we will take some more question if some question left from the from the attendee. Yeah. So we are going through here introduction of artificial intelligence. So this is one short video, which is the sources from the Royal Society. This is a very nice video I'm going to represent, because as we know the characteristic of the image, like the image is speak more than 1,000 words. So I believe this help if someone has a not background in AI or not familiar with AI. So maybe like you can get some of the knowledge about the AI and how is real application in our surrounding. So as we see here. So this is AI. What is the AI? The first question is, what is AI? I'm just pause it. Yeah. So the first question is, what is AI? I'm sorry for that. So AI actually basic is a science. As we know, we want to make all the systems should be automated. So means we want to build some of the algorithms, some of the technique. We want to, like, if you are doing something manually, we want to make this system should be automated. It should be the artificial. That's why we call artificial. Means intelligence in the terms is self-intelligent. We want to make our algorithm that should be helpful for some application, where we don't use like some manual. I'm sorry. And also we can use those of the algorithm to like with the different application. So as we can see here, I'm going to just make a play of this video. So, yeah. AI already covers subtypes. Yeah, so there is some different application. As I mentioned, there could be application in the medical imaging, because radiologists or the doctors, they use in medical imaging to get diagnosed or get predict some of the information. Another could be for the satellite images, like the astronaut they use. As we seen recently in the last year, there was some rover I'm sorry, the ISRO wanted to send it on Mars. There was some failure, but it's like they use artificial. Even though some other researcher with a different application, they use artificial intelligence. Means the idea is that we want to get machine to learn from itself. It should not be it should not be a manually. So we want to get trained machine that can learn our like a coding, what the program we want, what the objective we have. It should be the automated. So if you're going to next what is machine learning? Because it's a very fundamental thing is a machine learning, how machine learning works actually. So in this term, machine learning it has some of the structure like a basic framework, because if we want to make some of the algorithm and we have some objective, take some example here. Suppose we have some images or video or the text information, yeah, and we want to classify some of the images. Suppose we have two different kind of images as an input. One is dog, another is cat, and we want to classify. For us, for the human being, we can classify because we know from the childhood what is dog, what is cow, what is different animals or the different objects. But for the machine, we need some of the informative features that could be helpful, where machine can assume, predict some of the things. So idea is that in the machine learning, if we have some kind of images, as I mentioned, just take an example with a dog and cat, suppose. We have some feature extractor. Feature extractor in the terms, we have some feature extractor, like if some of them is familiar with the image processing, computer vision. So we have some like local binary pattern or the histogram gradient histogram we computed, some of the GLCM. So those are the features is like we call that handcrafted features, means is a hit and trial, means we don't know which of the features for those images would be useful. We use them and try to build our model and trying to predict what is the performance of our model. So means we have this feature extractor in the second block. What we are seeing here is a manual handcrafted features we're going to define with the machine learning. And once we use those feature extractor, so the work of the feature extractor here is take a input from the image or video and extract some of the information. So information in terms of images, what could be the information? So the information could be the pixel intensity. Suppose you are seeing the very bright pixels in an image or very high contrast image, that could be. Or there could be some pattern in image, like you are seeing the trees or some of the object. So if there's some pattern in the pixels, and there could be some like hidden features as well. So those are the handcrafted feature here in the second block, is trying to extract those features. And once you get features, you try to apply some machine learning algorithm, which can classify if you're using for the classification. So you can just use some of the basic fundamental algorithm, traditional algorithm like support vector machine or the k-means or different algorithm. So we can use to classify. But as we can see here, the hard thing here, the coded here, we need to define the feature extractor, because this is a key point here. Because everything, the output, what we are going to get it, and the output is based on the feature extractor. Means if we can extract the feature which is very rich, means the output will be very good. Means your classification or the segmentation or detection, what you want, the output will be very nice, is promising, you will get the accuracy. But if your feature extractor is bad, it's not helping, it's not helping a lot from your images input data. So the output will be not be good, because it's a machine, it's not a human being. We can just put the images and get predict to assume it will give us 90 or 100% accuracy. So that's why, so in the machine learning, mainly two type of learning we use. One is supervised learning, another is unsupervised learning. So there will be a question arise, what is supervised learning? So what we can see here in the supervised learning, for the supervised learning, we need a data and annotation in terms in the ground truth. I can give you one very short example. Suppose if in a home there's if baby born, yeah, and after 1 year we want to teach the baby, yeah, we want to get like speak some of the like father or mother or some of the different names, yeah, we just try to give the some of the information to the baby can get to learn even for the language, if he can speak or she can speak English or Hindi or Spanish or French, that could be, means we are giving some information which is we already know to the some where what we want to whom we want to give, means in this case the parents we have is the annotation, means the ground truth, the label data what we seen here, and we are transferring this data, means the knowledge to the baby can get to learn those of the information, could be the language, could be some activity, could be some motion. So means for the supervised learning, we need our data. Suppose we are talking about the images. So we need an image, but we also need a label. Suppose I give you two image. One is a dog, another is a cat. And if you don't know, if you never saw, it's very difficult to identify which of them is a dog and cat. It's very difficult. So for this, we want to give the label to the machine, to the algorithm. Yeah, this is this label is this image belongs to the dog, this image belongs to the cat. So once machine knows these are the labels, so at the output that would be interesting for the machine, that can easily to classify. Even the accuracy could be the higher, could be the lower, but the sense is that machine give you the some output which can belongs to the some of the classes. So ideally in a machine learning, in a deep learning, when we are training our model, when we are building our algorithm, we are splitting our data into three different parts. Here I have shown two, but the another is three. Is first is training set, means which data we want to use it to train our machine learning algorithm. Second data split. Suppose take an example again. I can give you an example. Suppose we have total 100 number of samples. We are going to split this 100 sample into three different parts. Suppose we are going to take 70 samples for the training. Because why we are taking 70 samples, more number of samples? Because we want to get model trained. Because if we will give more number of samples, that would be easy for the network, for the model, any model, it can get more information. But in the sense, if we will give the less samples, that would be not be sufficient for the model to get to learn the features. So the first set we made in 100 samples, suppose is 70 samples, which belong to 70% of the training set. And the 10% you can take is up to us, is we can split a set in the two set. We have remained 30% remain. So we can do 15%, 10% for validation. Yeah, validation set is very important because we want to get our algorithm, the model should be optimized. Optimized in the terms where the loss should be minimal. So in this sense, the validation set is going to help us to optimize our algorithm. And the test set, we want to use this test set, another set, which should be unseen to this process. It means once we are training our model, any of the algorithm, we want to use training set and also the validation set, some of the percentage of the validation set. But if we want to predict our model, means we want to check our model, how model is accurate, we want to give the unseen data, unseen images, unseen videos to the model to predict and to verify the accuracy what we are getting is actual or not. Suppose if you give the train sample for testing, means model already knows how's the pattern of these samples. So you will get 100% accuracies in this sense. So idea is that once you train your model, so machine learner here is going to learn the pattern you have, what the model you have defined. And once you train your model, so you have a one model where you can just put your sample as a test set and you can just predict the expected labels. Label could be, as I gave you example, it could be a dog, cat images, or could be any of them you can imagine. This is just example I can give you here. So this is a fundamental information of how we train, how we validate, and how we test our machine learning model. And this is the ideology, this of the, the function of this splitting a data. We also use in a deep learning in a similar fashion. So what is a deep learning now? So now in the previous slide, we have learned what is the machine learning and what is the difference between the machine learning and deep learning. So there's an example here I can give you. So what we have seen, there's an image here we're seeing. Here is the feature extractor. Here is the classification and here's the output. The point here I want to mention, as I told before, feature extractor is a very hard coded. We need to define specific feature extractor, means which kind of features we want to look. Suppose this is a dog image and we want to get extract some of the information of this dog shape, means we want to get the age information of this dog shape. So we want to specify those feature extractor here which can learn, which can give the output, the pattern, the features which belongs to the shape information or the age information of this shape. But in terms of the deep learning, this is the beautiful thing in the deep learning. You don't need to define any feature extractor, because here we have a convolutional neural network. We are going to see later what is a convolutional neural network and how is working. But the thing is that how you differentiate. Suppose once you have an image in the deep learning, you can feed this image directly to your network, which is automated feature extractor, and it can extract all the features, relevant features, what you want to look for, and give you the output directly. So in this sense, the difference between the machine learning and the deep learning is that you don't want to specify any of the feature extractor. Deep learning can automated learn those patterns, those of the features, and give you the output. If anyone has a question here until this point, so no, we can move forward. Thanks. Okay, so in a deep learning and imaging, so what we have seen is that we got in the previous of the slides, we got some basic fundamental idea how the machine learning and deep learning works in a theory. But if we are going to be used in a image processing with the images, how is working? So just to get you knowledge, just to put you in knowledge, deep learning, it has a combination of the convolutional neural network. I will show you later how the convolution perform. And there's some of the function that helps, like the max pull operation, some of the strides. I will show you later this as well, how it's working. So I can just give you idea, basic fundamental idea. So suppose this is an image. We want to feed this image to the deep neural network, which is a stack of the convolutional neural network, what we see here. And at the end, we want to predict some of the classes. And what we are seeing here on the top is the pattern in the initial layer, because in the deep learning, in the convolutional neural network, the initial layer, suppose in the very beginning, first two or third layers is going to learn some of the spatial information. Spatial information in the terms could be the age information of the shape. Suppose this is a burst we are seeing, could be the shape information, could be the age information, could be the intensity information. But as we are going into a deeper, we are losing a spatial information. How we are losing? Suppose the size of the image here is 224 by 224 by 3. 3 is the number of channels. Channel means is the color of the image which belongs to the three channels, which is RGB, red, green, blue, what we call. So once we feed this image to this network, so we are downsampling. Downsampling means we are just dividing this image by 2 every time. There is a reason why we are dividing. I will show you later, but we are dividing these image after some layers. So what we see here is dividing. If you see 112 by 1, this one, and it's 56 by 56. And as we are going into a deeper, so initial this point, we have a spatial information. As I said, you can take the example here, 1, 2, 3, these some samples. But if we are gonna like I take this example from the very bottom layers, what we are seeing here, where's my cursor? You see, we are losing our spatial information. Means once you have just downsampled your image, if I just put this image in a very small compressed part and extract more relevant features, you will get some of this output. It means this is the output. What we are seeing in the bottom is belongs to the channels because it's a number of filters, which is called as a number of channels. We called it in image processing computer vision. So here, what we see here, how the convolution work. Because this is a very interesting point here, the convolution point, because it's a base of the deep learning, we have to understand. And the max pool, as I mentioned, is the max pool operation here. So we have to understand what is a convolution. I think most of them you are familiar with the convolution. So if that two of the mathematical operation is going to get multiplied or get connected, we are going to get third of the functions. Yeah, so is a convolution. Suppose this is your matrix. What we in a bachelor time, even we read in the first year, is a matrix operation. So suppose this is like a 3 by 3 matrix, and the kernel matrix here is a kernel size. We have kernel size means like the size of the filters. So filter, I think some of them we are familiar with the filters. Filter extract the some of the, like we use some of the filters to get low, like a high frequency, lower frequency. So these are some filters we use to. So these are similar kind of filters we use. So suppose the filter size is 3 by 3 matrix, and this is a convolution. We are striding, means we are sliding this convolution, these filters, like this one, the matrix one by one. So the operation between these two, you can see here, we are getting some values here as a new matrix. So once we get new matrix, so you already convolve two functions, get the one output, and now you have to decide how we can get the most informative features. Suppose here, we are here and we apply this image to on this point, and we apply the convolution. Okay, and once we got, we convolve two of the features here, but we want to get some of the information what we look for. So information, how you will get, we are using max pool operation. As I said here, the max pool means the downsampling of the image by 2. It could be you can use 3 by 3, you can use downsample by 2 by 2 or 1 by 1. This depend upon how we want to optimize our model. So if suppose we are using 2 by 2 matrix, the kernel size suppose here, and the stride is 2 by 2, means this is, suppose take example, this is 2 by 2 matrix. So we want to take the highest value from this 2 by 2 matrix. So in this 2 by 2, highest value is 9. So you can see the output here is 9. So idea is that once we use max pool, and here you can take another example. Suppose we are here. So in this matrix, the 7 is big. We can get here. So we can make another matrix. So the purpose of using max pool, we want to get downsample images. The first motivation is that we can reduce the computational complexity, means the number of calculation in terms of the matrices. Another thing, we want to take the highest, most informative features which is coming from those matrices. Means we suppose we are taking the most highest one, so other is not much very helpful for us. So we are just capturing the most highest one. So we can get those informative features, and even we can reduce the computational complexity. So these are the benefits with using the max pool. This is very common in the deep learning when we are building our model, convolutional neural network. We used to. So in the state of in the state of the art, we have different models like a VGG net. Maybe you can search on Google. You will find VGG and Inception, RSNet, some of them Efficient Net. So those are the models was defined on the ImageNet data, which is trained. These models are trained on the millions of images, natural images, and that can actually it can classify like 1,000 classes, natural classes, which is you can imagine what you are seeing in your surrounding, which is all those are included onto those classes. So why deep learning is needed this time? Why people are not using the machine learning? What is the difference between how is make differentiate in terms of the performance? What kind of data we need to be? So as we can see in a graph, as we increase the data, because as I said, if we increase the more number of samples to feed our network, we will get a better performance because we are giving extra information, extra features to the network, to the algorithm that can learn. So means deep learning model can learn the discriminative features. As I said earlier, if you are giving two different images, just take example again, like a dog and cat, it can learn the pattern. What is the difference between the in a dog, in a cat? It can discriminate what is the difference. It may be from the tail, from the shape, from the eyes, from the nose. Yeah, it can learn those patterns. What is the difference both of the animals? And if we talk about in the medical image, I'm just touching on some part here just to get correlate to the medical imaging here. So if we want to use the deep learning in medical imaging here, so it can also give you some of the prediction. If you want to detect some of the lesion, means a tumor inside some medical imaging, like could be the in MRI, could be the X-ray, in mammographic, or could be an ultrasound, you could find out actually. And maybe you can also classify those of the tumor is cancer or the non-cancer, or what are the risk with these kind of tumors actually, and how it could affect you. There's several applications. And also, as I mentioned, with deep learning, we need labels. Labels means we need some of the information, what the images belong, which class belongs to. And also nowadays we have open source tool, various model available. So open source tool means we have a open, because nowadays people are working in a Python programming language. So we have enough open sources. We can get some of the like existing models from there, and we can just play with it, and we can learn some of them. If you are not familiar with this, you can just download the code from the GitHub, and you can just learn, and you can just feed your data, and you can just play with it. And also very important thing for training a deep learning model, because if you're going to train your model on CPU, that will cost you, means it will take a longer time. So for this GPU, we have a graphical processing unit and DPU as well. So if you're going to train our model on these GPU and DPUs, it will take you very short time as compared to the CPU. And there's also like open access. You can use it from the Google, it's called Google Colab, or from the Amazon AWS. So there's lots of resources now, and you can, like, if anyone wants, they can use it. And also in a deep learning, how the task could be useful. It means what are the things you can do with the deep learning. You can detect what you want. You can detect the object. I will show you the images, how it's detect. You can detect I'm sorry. Hello, can you repeat your question, please?
No, sir, it is fine. It is
Okay.
fine. And Ms. Chitra Tiwari, please turn off your mic. If you have
Thanks.
any question, then you can ask to our honorable speaker. Okay. If you do not have, then please switch off your mic. Ms. Chitra Tiwari, please.
Yeah. Okay. So in a deep learning, as I discussed, like we have different applications. We have some kind of application. We could detect some of the object, some of the scene scenario. We could detect some of the different application, means detect some of the road light, some of the trees, some of the roads. So we have different application. We could segment some of the organ. Segmentation means we are going to we segment some of the regions that could be used for further analysis. Classification is the task, how we could classify some of the object or some of the disease, could be different application. And the reconstruction, if you have, just take example, you want to reconstruct some of the images, there's some application as well. There's a broad area in 4 domains. So there's some real application, and in real life, there's some application in our real life, and we always used to, like, just take example, if nowadays everyone has a smartphone, I believe, and if I'm going to take a picture, if you see, like, you observe in a smartphone, there's some of the, like, a box is coming just surrounding to your face area. This is called a face recognition, means it's trying to capture your face. So how it captures is trying to get some of the key points. Key points means it's trying to get some of the pattern, how your nose in a shape, how's your eye structured, your lips, or your cheek or the forehead. So based on some features, it's trying to get your face recognized. So this is one application we use for that, very common for the mobile cell phones. In terms of the medical imaging, if we talk about here, we have seen different kind of imaging modality images here. One here is for the breast mammogram, is a brain MRI, and here is also for the abdomen. Is for the retinal, for the eyes, fundus images, and some for the cardiac, for the heart, for the lung, is for the lung CT scan, is also the for the skin images, dermoscopic images, and this is the histopathological images. So these are the some images modality which is going to be used to, as of we're going to extract those of the feature from them and use it for some real tool, how we could build it some tool for the radiologist or for the clinician, those who want to use and get predicted. And also another application for satellite imaging. So as we know, satellite imaging, what we are seeing is very small area in a pink color, is a building or maybe some streets from the top height, what we're seeing here. So it could be useful if you wanna like make a map, or you want to make a like compute some area. Suppose you compute these of the information with using deep learning, and you have this structure information is stored in your data bank, and you want to take again after 1 year, 2 years, then you will be able to get track what are the changes happen on this area. So these are the some like application in also in satellite imaging, also in a food recognition. Like when is very funny, like if you're eating food in a restaurant and you want to get control of your like some of the like doctor suggested you some of to like don't take a high oily food, or if you have some of the disease, liver disease, or you want to get ignore some of the food which you don't like. So yes, there's is like deep learning help here is to find out the nutrient inside a food, and where you are eating those food, which place you are eating, and how much time you are spending in a restaurant there. So there are some application that could be useful in a, like in a healthcare. You can get control of your health. And also, as I mentioned here, another application is for the semantic segmentation. As I mentioned, semantic means we have different information, the semantic information. So as we see, all the person building all the structure here is labeled with the some colors. So means we are giving each color belongs to the each class. So means the street light here is belongs to the each one class. The woman here or the cycle here belongs to the another class, or the road here and the building here. Everything what we're seeing is belong to some class. So we want to use the semantic segmentation model to get segment those areas, and there will be question arise, what is the purpose of doing semantic segmentation, why we are using those kind of model, and why we're making this complexity, and why we want to track the road and higher the streets light. Just take an example. If you want to make automated driving, and we want to get our automated driving system learn how to differentiate if the car is running on a road, how it could differentiate the real challenges. Real challenges in terms there could be some street light, and there could some person is crossing from the road or is walking. So those are the application here. What we're seeing in the segmentation, those are going to help those automated driving. This is one application I just mentioned here to just make automated driving, and model can get learn from those, and it can work. And also is object detection. Another application means you have a different objects. Suppose this is a car, van, bus, human, and you can see, you can just detect those of the organ. This is like nowadays in India, people like using in the IRCTC, when people are, I saw the news there when they are cooking a food in a kitchen also to get tracked. And also some other different application is used to in automated drive. It's not automated driving, I'm sorry, for the license plate detection. Yeah, if someone is making a false is crossing the road or is not following the traffic rules, that could be very helpful. So those are some real application we feel sometime in our life, and maybe like we will see later as well. So the next part, as we discussed in the first section, we were discussed about the machine learning concept, AI concept, deep learning, and some application in like real challenges in a real domain and how it's working. But the point is concentration the main concentration of this talk is to focus on the medical imaging, because this was an idea to get you, just put you in knowledge, because we want to use some of the terminology here in the medical imaging. So what is medical imaging? Because this is the first question arise, and what is the purpose of doing medical imaging? Suppose, just if you take an example, any of them, just take an example from, suppose take a breast mammographic images. And if we give this image to the radiologist, maybe radiologist can get, if he or she has experience, it can identify, oh, this is like a tumor area, some of the brightest spots here. Maybe it could be some cancer, or it could not be a cancer. It could be identified by some of the histopathological tests, some of the clinical investigation. But if you want to use imaging information, how it could be useful means we want to use those images and going to train our deep learning models to learn some of the patterns. So if we want to feed this model and we want to predict some of the things what we are look for, means we want to predict the size of the tumor. Our object is that how big is the tumor, or where is the tumor located in the breast, or this tumor is cancer or not like a benign, is benign or malignant, means it's cancer or non-cancer. So there could be some different applications. So idea is that we are going to use these imaging modalities, different modalities, and we try to build automated system that can help as a second decision maker for the radiologist. Means radiologist has his or her own decision, but it can be verified with the automated tool. And also the main advantage that to build automated tool is that we can save the timing from the doctors. Means if doctor is going to analyze those images, it will take some few minutes. But if you're going to make automated system, that could be in a millisecond or could be 1 second, 2 seconds. And also in a human, we have a chances of error because we are not the 100%. So we could make a mistake. So making a mistake in a medical imaging part means we are going to play with the patient health. So this is very serious and this is like very critical point here. So that's why we want to get examined 2 or 3 times with the different knowledge. So knowledge is that one knowledge could be comes from the doctors, another knowledge could be comes from the our model we are going to build it. So what is the purpose medical imaging we discussed, but what is the main aim to whom we are going to use it, who is going to get benefited? So idea is that suppose we are extracting those of the images from the patient. So the radiologists can use this image to diagnose the abnormality in a body and can make an accurate diagnosis. And end user means the patient can be get benefited. Means if doctor can diagnose well, it can treat you very well. It can give you some medicine, some of the medication and some of the treatment, and like you will be after some time you will be get like cure. And also for the computer researcher, for us, like as we are working for the computer scientists, we need those images to get analyzed and get to train our model. Means we need also the help of the doctor sometimes. Means where we could generate the labels. Labels means we could identify, because we are not the radiologists as a computer scientist. We don't know what is this. So we need to be get identified from the doctors. Doctor should give us the information, which is called as a ground truth or the label. Doctor should mark this area, okay, this is area which belongs to the tumor. Or if doctor could make us some histopathological test to verify, or biopsies, like those of these tumor are the cancer or the non-cancer. Means we need information sometimes from the doctors to get identified to train our deep learning models. And that could help to build automated diagnosis system. So as I mentioned, automated diagnosis system is what? Means this is the main purpose of making a CAD system. In a short, we can call as a CAD. Is not to helping just not to diagnose the disease, but also helping to the radiologists and save their time and also reduce the error. Means in a human we have a chances of error, but if we could reduce the error, that would be helpful for the patient, and even for the doctor can make an accurate diagnosis. And that would be helpful. Means if you want to classify some of the disease, or if you want to detect some of the tumors, or could be some cysts, that would be interesting to make it. So the CAD system is a kind of tool we are building, making an automated tool that is going to use it for some clinical perspective. And the first question is that here arises, as I mentioned, the imaging modality, but we also get to know how the imaging modality is going to work. Means how the first I'm going to start with the ultrasound. Maybe some of them are familiar with the ultrasound, make some abdominal ultrasound, or some of them, and we observe like we are seeing ultrasound is very dark, as it's not very clear. There's some shadows, and we think, oh, this image is very poor. We can't get any of the information, but radiologists can get the information what they want. So means how the ultrasound is working, how this technology is working, how the image is extracting from our body. So the idea is that just play with it. So ultrasound is using a probe. As we know, is a probe is a piezoelectric element. So as we see here is a piezoelectric, these are the elements, is a piezoelectric element we are seeing. So piezoelectric, from the piezoelectric element, we just push just produce a sound waves. Those sound waves into a body, and then like propagate. Means is based on the acoustic physics rule, on the reflection rule. Means if some wave is going to inside your body, it should be reflect back. So the working of the transducer of the probe is to release the sound wave, and also to get the knowledge, means to get the waves is coming through, means to receive, transmit and receive with the same piezoelectric element, and it's very faster in a real time. And here what we're seeing is example with some organ. So what we're seeing here is going to convert, once we get those of the information, the reflected wave, we can get some of the images like this, what we're seeing in the ultrasound. So this is a very fundamental concept of the ultrasound is how it's working. Is after that, another modality is coming for the X-ray. It's very common X-ray, and you can find it we can find it very easily everywhere. So this is an example of the lung X-ray. And nowadays, like in the last 1 year, is very common because of the COVID, and doctor says to be used for the lung X-ray could be the some of the key finding to diagnose how much the lung is affected with the infection. So the idea is that X-ray is imaging that create a picture from the inside our body. And also it's like this image I mentioned is a pattern from the lung area. We can see two different areas here from the lung, and also the tissues inside our body which absorb some of the radiation. Radiation means what like a radiation we are passing through the body. So means in a body we have a calcium, means the bones. So what we see, the calcium absorb most of the radiation. So that's why we are seeing those bones are white. But also these areas here is the soft tissues here, which are not absorbed as compared to the bones, and that's why it looks gray and black here, some of the areas. So these are the imaging with the X-ray. So now we are moving to the MRI. So magnetic resonance imaging, which use magnet and radio waves to create a picture of the interior of the organ. Means, suppose this will take an example with the machine, and we are going to get insert into machine, and this machine is full of magnets, completely very strong magnet, which generate a generate a radio waves, and you will be get like a radiologist will be get some of the images in a computational form, and it can detect some of the abnormalities. And some of the cases, like in some of just take an example with the cancer or some of other cases, the doctors, they inject some of the contrast agent. Contrast agent in the body means to find out some specific tissue. Means if they inject a dye, they called it the contrast agent. So it will go inside the body once they inject as an injection form, and it will highlight those tissue which is going to react. So these are some also doctor use some of in some specific cases. Another is imaging modality. Those are the imaging modality which belongs to the radiologic images. Radiological images means which is comes from the we can see those images in a grayscale form. And but these images here, radiology images, not this is like a camera-based images. Means this picture could be we can take from cell phones or could be any device. Means it's not a radiological images. So these are the camera-based images we called for the application we are going to use it is for the skin lesion. Suppose in the skin we got some moles or some of the abnormalities in the skin, we can capture those images and try to find out some what are the abnormality. Means if the infection in a skin is just only normal infection, or it could be the some of the non-cancer tissues, or it could be the malignant, it could be the skin cancer. So these are the some cameras that would be very helpful to identify the disease. And also for the eyes, I think most of them are very familiar with the eye cameras, and it's very common. And these are the fundus camera that used to capture the retinal information and find out some abnormality. So here we are seeing, as ophthalmologists, they use this kind of camera to find out some abnormality in what are the changes going through inside the eye, and what are the abnormality in the retina, or maybe I'm sorry, in the macula, or how it could be. So those are the information which is coming from the fundus imaging camera. So we are going to see the real application, what I've been built doing my PhD work. Even I am working, some of the work is like practical work, which I have been building some of the tools which doctors is useful for the doctors that could use it. So these are some practical application which is use the AI technique, deep learning technique in medical imaging. So the first work we are going to get a practical knowledge about breast cancer analysis. Second is we are going to get more information about the automated tool for the skin lesion diagnosis, as I mentioned in the last slide. Also for the retinal image analysis, and the very latest is the identification of COVID-19. So means because it's very popular in the COVID-19, because there's now vaccine is coming recently in a 1 week. But the thing is that before that is the whole year was very dark, and we were trying to find out the way how we could cure the patient, or how we could early diagnose the patient, those who are symptoms or non-symptoms. So the imaging modality, like this imaging, like CT scan or the X-ray, plays a key role also to get verified some of the patient. Okay, if the patient has some of the symptoms or some of the infection found in the imaging, okay, then doctor can just make a refer to the RT-PCR or some of the antigen tests that could be. So the first application is for the breast cancer analysis. So the first question arises: what is a breast cancer? Because it's very common in a woman. Because in every 8 women, like it's very common. It's like if like a woman is not be no, not much aware, there could be a cause. Because breast cancer is busy which cells, where the cells grow out the control. Means suppose this just take this animation is a breast area, and if that some cells is start to grow, and sometimes it's just start to spread it. So that could be some of the region, some of the place is like could be cause cancer, and that can is like challenging for the in terms of the health. It could be life threatening. And also these cells form a tumor, as I shown in the mammographic images earlier, like a bright area. So that could become that these cell could join and become some of make a form of the tumor. And also there's some important like a main like a part of the breast here, what I want to discuss, which is made of the lobules, duct, and connective tissues. And also some of the times, if the woman is not aware and not get diagnosed early, those cells supposedly spreading start from here on these areas surrounding the nipple areas, and that could be spread to the lymph node and just go through the your neck area and to the approach to the brain, or could be go through your abdomen, and maybe it can harm of some other body organ. So this is the actual work, that is the practical application. The aim was like how we could avoid the biopsies. So just take a first look here. What is the biopsy here and how it could make? So suppose this is an example, is animation. If doctor wants to get assure is the tumor or the cells is benign or malignant, means it's cancer or non-cancer, or it's just only the normal cells, is use this technique, the biopsies. Mean biopsy is very painful because it's going to take, as we saw here, going to take a tissue inside your organ from the breast areas, and which is very painful. So what we have aimed, we want to get avoid, or it could make a decision for the radiologist. They can decide the patient need to be biopsy or not. Means we want to build an automated system, or the doctors, for the radiologists, for the oncologists, they use our system and to get predict this tumor which belongs to the cancer or the non-cancer, or even for the cancer first, even for the cancer, because in the cancer, if person like a patient has a cancer, it has 4 different subtypes. We called it molecular subtypes. So molecular subtype is luminal A, luminal B, HER2 in triple negative. This is medical terms. So in the most of the women in all around the world, those women who diagnose a cancer, more than 70% of the cancers, which is belongs to these 2 classes, luminal A and luminal B. And but others, HER2 and triple negative, what we're seeing here is that even you see this number of samples which belongs to the some population is less. Means is that this 2 type of cancer, HER2 and basal-like, is very aggressive, means very dangerous type of the cancer, means you're approaching to the final stage of the cancer. But nowadays we have a good early diagnosis system. We could predict, we could find out the cancer symptoms of the tumor or something is originating, and we could find out, and we could avoid these 2 different steps. Means if you diagnose early in these 2 subgroups, if patient has a cancer, that would be like a good chance to get treated very well. So these are some factors in a clinical perspective, some of the body receptors which belongs to the decide based on the histopathological information after biopsy information, which decide which kind of molecular subtype, which kind of cancer patient has. So if you see here the prognosis, if patient diagnosed luminal A or luminal B, prognosis means the output in terms of clinical performance, patient get be cured, means is good. But if is diagnosed late or cancer is spread from the body, from one organ to another, so means the prognosis is very poor. So that's why we want to use here, if you see these 4 different small tumors here, if I will give this image information to the radiologist and just tell them, okay, these are the 4 images I'm giving you, and now you have to decide which molecular subtype, even if the radiologists have 30 years of experience. It's like very challenging for the radiologist to get predict. Means we can't predict if we know, visually we don't know some of the features, how is like informative for us, and we don't know. And what we made in this building an automated tool for make a analysis for this work, we try to find out firstly we try to find out what are the visual features. Visual feature means what we can see from our eyes first. Means if we can see something from our eyes, that would be easy for the machine, for the algorithm. Means we can feed this information, or we can penalize our model as in a cost function that could learn efficiently. So what we are saying, we build a CAD tool. So in a CAD tool, suppose this is the mammographic images from one side of the breast. We try to feed this image to detect. I will show you the videos later. Is detecting a tumor. Even we see here is very small tumor. Some of the cases, if the radiologist is not so much experienced, or maybe from our eyes, we could miss some of the small tumor information. But if we have an automated tool, it can detect some of the abnormal tumor, some regions, and we could get, after getting this region, we could get extract this. We called it region of interest. Means the region where we have interest to want to get the features. We want to extract the feature of this region. So here, what we see here, the image here is very dark. It's not so much. It looks very smooth image. But we use some of the pre-processing. Pre-processing in the terms, we applied some of the small algorithm just to improve the contrast or the brightness of the background and also the foreground. Background means the surrounding of these tissues, and the foreground, the tumor region. And here, this is like we use, because this is a very vast area, maybe if you want, we could discuss later, because this is the generative adversarial network is a complete whole domain of the network. We use those network to get extract feature from those images. So what we have seen here, these yellow color inside a yellow box, and this one is the feature we extracted from these images. And after that, we segment. Segment means we try to cut it off this area, means to locate this area. And what we're seeing is the output we got it here. So once we use the segmentation algorithm, first we detect where is the tumor. Once we detect, we've just applied this region of interest to our model, which is the conditional generative adversarial network. After that, we segment this area, this tumor area. And now the very important point is that, and the visual, if we know the shape of the tumor, that would be interesting for us. Means that was a very simple features from here. If you see the shape here, maybe this shape looks like very speculated, irregular shape. It's not very smooth. This is also the similar kind of the images. But as we are going to the HER2 and the basal, we are seeing the images like those tumors which looks like very round shape or the oval shape, or it's very smooth, means there's very less speculation. So I will show you why this is working. So idea is that for second stage, we want to look for the shape information. So we make another network, which is another like a convolutional neural network that can help us to classify those are the shapes. So means the shape, suppose this is the shape is coming from here, which is some speculated here. So it could be go through this class, irregular, or maybe some of the images coming to oval or round, which go for this class. So we use this classification network to predict, to identify the shape of the tumor. And after that, we build the model that can correlate with the molecular subtype, and also with that can help with radiologists. They can visually identify, they can get some of the visual attention. Okay, if the tumor belongs to the more speculation, more irregularity, which belongs to the luminal group. Means there is a reason I want to mention here. In a luminal group, means is very early group, is a subtype of the cancer, which is belong, as I mentioned earlier, which belongs to the 70% of the, in more than 70% of the women who diagnose this. So during this stage, the cells is growing, means cells is trying to get explore, means is trying to explore, is spread it. So means if the cell is spreading, means the shape will also be spread. We will get the information from the imaging point of view. We will see is like spreading. But once cancer, this tumor is already spreaded. So what we're seeing here, the shape is very rounded, or it's very smooth. Means cancer is like a large tumor, and also is not spreading much, is already spreaded enough. and is now damaging you some of the organs or could be others. So idea is that what we going to see here, suppose this is a tumor here. Just take an example. So we can see some of the small areas, some of the bigger areas. The model is predicting and giving you the performance, how the tumor is 99%, is confidence rate. Maybe radiologists can miss one of them, or maybe in the breast there could be 2 or 3 tumors. So that's why this is a benefit of the models what we're developing in a real time. That could be useful in a real time. If you're just scanning the patient, you can assume, okay, this is a tumor area or is a non-tumor area, or the tumor is a cancer or is a non-cancer. So these are some examples here we have put here just to visualize it. So how the model is working in the first stage. And after that, in a segmentation part, what we see, because first stage we detected, but in the segmentation part, our approach here in the last column, we are seeing our approach here. And these left area, what we're seeing is the grayscale images, is the X-ray mammographic images, is the input, means we are feeding this input, which is got from the detection model, from the model here. We got the area. We are feeding those images to our next level or for the segmentation to segment this area here or this bigger area. And we have been compared with the different models. Is existing state of the art, means in such community they have some models in the deep learning. So we have been compared. And if you compare, if we are just seeing on the right column, this is our proposal. The color belongs to the orange, which is the our model prediction, means this is the model predicted. The model we made it is a prediction from our model. And the red color, what we seeing is the red color, some small areas, red color or here or maybe some here. This one is the annotation, is the label from the doctors, from the radiologist, means this is the prediction from the doctors. And the orange is the prediction from our side, from our model. And we can see here how much is close to the doctor's radiologist opinion. So this is the benefit to make an automated tool. Like if you make automated, it will be very fast and you can get predicted very well. And also in a later stage, as I mentioned, so we pass the detection, we pass the segmentation of the tumor. The next stage is a classification, how we could classify the different shape, because the shape is going to is to play a key role to finding out the visual identify the molecular subtype of the breast cancer. So as I mentioned, we have used like a 3 to 4 different 5 layers of a convolutional neural network. It's very small network because we don't have much information. Here is like a binary image, is a black and white image, because we want to learn the age information, means the shape information, because we are not looking for the texture inside this. Texture in terms means the texture what we are seeing here, this gray image is a texture we called it. So we don't want to look, because we are looking for the age information. So is this network, a small network, was enough to get trained and perform very well. It was very faster. And we predicted, we correlated the shape of the tumor to the breast cancer molecular subtype. This was a complete tool for the breast cancer project. So another one is for the automated tool for the skin lesion diagnosis. So as we see in the skin, the motivation was that in the skin lesion, in the dermoscopic images, we have some difficulties. Suppose if you have some of the abnormality in the skin, and we want to get approach to the doctors, and like it's for dermatology, and sometimes doctor get assume or maybe make some of the tests, some investigation, clinical investigation. We want to make some automated tool just to capture the image from your cell phone, and if you already have a model trained and it's like you make a prototype in your as like application we use in cell phone, Android application or the iPhone application, and you just click a picture of your subabnormality of your skin and you can just get predicted, means this image belongs to is like a normal, it's normal like some of the infection, or it's normal images, it could be treated after some time automatically, you don't need to approach the doctor, or this images could be the cancer, could be the cancer features, you need to approach a doctor, because sometimes we feel lazy, we don't want to approach. So in this case, if you want to build this like application, that would be very interesting, and is like all of the people can reach the application. So but we have some challenges here, because when we are building our model, we try to expect like try to give the as much as good information to learn, because we don't want to give any wrong information or any kind of noisy information to the network. So there's some challenges is the presence of hair. Suppose we in a hair or in a leg or any other body organ, we have a hairs when we're clicking a pictures. So, or maybe the illumination changes because each skin has a different contrast and different is different upon the people's. And also when we are clicking a picture, there could be the quality of the image will also affect, means your camera, how your camera is working and how's the quality of your camera. And also some of the abnormality like difficulties, you will not get the boundaries. Like it's this example, yeah, you don't know where's boundary ends. Here we can assume the shape of the lesion, this tumor, this lesion area is somewhere this shape, or maybe it's like a very oval shape here, but here in this image you don't know how it's spreaded. So we have some of them difficulties when we want to train our model. But as from the dermoscopic, from the dermatologist view, they have some their clinical rule, because if they want to predict some of the assumption, they are seeing those images in a different perspective. Means they are trying to identify these images are asymmetry or not, these images contain the border or not, what is the color of the images, and what is the structure of the images. So these are some factors from a dermoscopy point of view, from a dermatology point of view, which affect where they can get diagnosed some of the early symptoms of disease. So here we can see we try to get those information, we try to segment those of the lesion accurately. And for this we have been participated. It's it's a challenge last 2 years, and we got it's like an international challenge openly, and we got a very I think 6 or 7 rank all around the world there, as I remember. So we can see how this working with the different image difficulties. So what we're seeing here, and in the background, we have a lesion here, but the area in the light yellow color is our model prediction. What the model based on AI deep learning algorithm we have built is accurately can segment those area, means get those areas. And after that, it's very simple. Once you get those areas accurately, it's very simple for the network. It get predicted based on the features, means this image belongs to the some cancer or the non-cancer, or is a normal. These are the symptoms. So these are some of the examples. You can see some of the bigger areas, some of the small areas, some of the artifacts is a hair or some illumination. So it's working very well, and it's is achieve very high performance in terms of different data set. We use public available data set and also evaluate our algorithm on the different models we have been used as well. So this is one application for the skin lesion. So, and also another application is for the retinal image analysis for the eye. So as we know, the glaucoma or the diabetic retinopathy is an eye disease. So there will first question arise: what is glaucoma? So glaucoma is a disease when the intraocular pressure in the eye increases. So it can affect your optic nerve. So once it's affect your optic nerve, there will be a chance to lose your eyesight. So, and in a world like 12.3% of the person in the world is likely just feeling with the with this disease. And end of some of the research articles I've been read is like end of this year is like few weeks, 2 weeks remain now. 80% of the 80 million of the person will be affected by this disease, glaucoma. So means it's very common problem. But if we could treat early this glaucoma or diabetic retinopathy, means we can save the eyesight and we could improve the quality of the life for the patient. So the retinal camera, as I mentioned, as I shown earlier, is capturing the different kind of images. In the images could be here. What you see is could be the here. What you're seeing here is the optic cup and optic disc here. And what we are trying to make, we want to trying to make our automated system which can detect those areas to get diagnosed accurately. Means to detection of the areas which plays a very key, which plays a very important role to make an accurate diagnosis. So I can just show you here one video again. What you see here, these are the optic cup and disc area, and it's trying to get this only detect those regions and is trying to ignore others. So these are the models we have been built which can only concentrate on that area. And suppose for the ophthalmologist, if he or she can get those areas, and it's very easy for us to get predicted with our models. He or she can get assume what other disease could be after this step. And also for this purpose, we also use make a segmentation. So here in the black region on the right video, what we're seeing here is the optic cup here with a small region, and the bigger region is the optic disc. So we want to make a segmentation of the both of the regions, because which is very important for the ophthalmologists to get accurately segmented both the region for the further diagnosis. So what we have seen here, we can see how is model is learning those patterns and how is segmenting those of the areas. So the good thing is that those of the models is very easy to get translated to the some of application, could be the mobile application or for the camera application. So those are some benefited from here. It's easy to translate it for the clinical purpose. And after that, yeah. So another application is for the identification of the COVID-19. So as I mentioned, COVID-19 is very like it's pandemic, and we know like we are trying to get just overcome this from this problem, this disease. And earlier, like we have lost like millions of lives, and it's still very important because most of the strategies to finding of the COVID is based on the RT-PCR or the some antigen test. But RT-PCR and some other is like they have a sensitive. It's not to be very much accurate in some cases, or some of them is like 70-80% give you the right prediction. And also is, as we remember some of the days, even in the India, even in the some of the countries like Spain or Italy or USA, even where we are, where the number of patient is high. So how we could control those of the patient, and how we could scan those of the patient, those who have symptomatic or non-symptomatic. So idea is that RT-PCR is a very gold standard technique, like clinician, the doctors, they used to. But idea is that how we could use another imaging modality, how we could find some of the features from the lung CT scan. Suppose we are going to take a CT scan of the lung. What are the features which can be useful? We could make our model that can help to predict identify the infection, COVID infection, because infection in the lung could be a different type, could be a pneumonia or could be normal infection, or what is the difference between the pneumonia and the COVID infection, yeah? Because it's very sensitive to learn those patterns with the model. And for this, we have been made our model because making for the doctors to go through the PCR is time consuming, because for the PCR we have to wait 5 to 6, 8 hours depending upon the conditions. And if you have imaging modality and we could predict in a real time in a 1 or 2 second or in millisecond, that could help for the doctors, for the radiologists, where they can, okay, if some patient came, okay, they can just put in a like a lung CT and they could identify, okay, this patient has some of the symptoms or some doubt, okay, we can refer to the RT-PCR. Or if it's totally clear with the imaging point of view, okay, this patient has not be COVID, okay, maybe if there's some symptoms, maybe this patient can maybe return back after some days. So in this way, we could save our resources, time, and also the efforts as well. So for this, we have been built some of the tools. So what we here seeing, like here, I took some of the samples from the lung CT. This is some publicly available data we have been used from Italy. I think I remember it was released from Italy, and this is some of the infection what we are seeing here. Some of the infection which belongs to the COVID. And this infection is very important because in the lung CT, we can get of the most of the informative features, because CT is a number of slices, means we have a number of frames, different frames of the images. And what we're seeing in the red and this mapping area is trying to highlight those features, where is feature located. So what we're seeing here is the more highlight red region is belongs to the some of the infected region, means is giving the explainability of the method, means we build some of the model, some of the algorithm, but how we could explain how this model is working. It could be a toolbox, but the toolbox, how is working, how you can explain your toolbox is how it's working. So this is like explainability of the method, where we could identify, okay, this pattern is belongs to the COVID, the region which is got infected. Those regions are infected from these are the areas we could see here, and that can help to the doctors or the radiologists or those doctor involved to treat the patient. They can identify, okay, these areas or the small area covered in the lung, okay, this patient has maybe treated well, or it need to be, if there are some other symptoms, could be moved to the ICU, or some of the other what kind of treatment could be, they can judge, means how much lung is involved because of COVID. And also, these are some of the areas, like we use some of the state of the existing model, state of the art model, and this is our own method, which is now is under review in a peer-reviewed journal, and which is Q1 journal is under review and it should be accepted very soon. And these are the output what we see here. So those areas is we are seeing in orange color, which is coming from our method. and is segmented very well those areas. It's trying to find out, even if you have like patient has very small infection region, we could see here or maybe here. But other method we are seeing here is producing a lots of false positive. False positive in terms means what we are seeing here in the green color means this is a false positive, means patient has not any symptoms here, any of the features here which belongs to the COVID infection, means it's giving you false result here. So in the diagnosis in the medicals, we always take care about the sensitivity and the how models reducing the false positive. So if we compare this method, what we have been proposed with the deep learning method, our own method, and the other tests existing in a research community, we can realize some of the method is failing and producing lots of false positive. This is the number we are using. This is, we call it DICE score, and this is called Jacquard score. DICE score we call means is computing a pixel by pixel score as compared to the ground truth. Ground truth which is made from the doctor, as I said, the red color, and the orange is our model prediction. And this is a Jacquard. Jacquard means we called is intersection over union, means how much this images overlap to the ground truth, means how much our prediction like predicted images overlap to the ground truth. So these are some statistical analysis, some of the quantitative analysis where we can get assume, okay, this model is performing well, and we can visually, we can also see like how models working well. And apart from this, there's an application for the lung CT, but you know, some of the cases like lung CT is not very common because some of the big hospitals or some of the cities areas, we have resources for the lung CT because it's very expensive. But if some of the cases, if we count, if you're in a village area, some of the outer area where we don't have these resources, how we could get identified from the imaging point of view? Because this is again the question. Because if you're going to count CT scan, this is very expensive in a cost. In the Indian cost could be the, I think 4,000 to 5,000 could be. I don't know. It could be somehow it should be. But the X-ray is very cheaper, and we could find it every place in a street and like everywhere. It's very common. And the X-ray, the cost is also very low of the X-ray, and if people can afford the cost of the X-ray, but for the CT, that would be challenging for some peoples. So the purpose of that, so we made some web-based or online identification tools, where this is a link. If someone wants to use it, they can go through it. And we use we train our model based on some images, which is going to give, if we are going to give X-ray images, which belongs to some of the COVID or the non-COVID X-ray, it can give you some of the prediction, means this images belongs to, in a real time. It will give you the this image belongs to the COVID or non-COVID, means this is also give you a identification, is a prediction. You can get it in a real time, but this prediction should be correlated with the clinical information from the doctors. So it's like a tool. We made it where doctors or the other clinician, they could get some decision, they could make it some decision, early decision, and they can just compare with some of the clinical information they want to extract. And as I mentioned, we realized that in a model, when we are developing models, we always need a data, because without data, we can't do anything. Because it's like to train any model, even machine learning or the deep learning model, because we need a data as a computer scientist. So finding in a medical domain, finding a medical data, that sometimes is competitive. Competitive in the sense, we need to get a data which should be the annotated, which should be the structured. Structure means it should be the well structured, means you have all the information what you look for. But also some challenges is that there are some of the standard of the data, means the quality of the data. And also patient information is very crucial, because without a consent from the patient, we can't use the data. So we always take care about the PHI, is a patient health information, is a patient data privacy. So like if patient is not agreed to give his data or her data for research purpose or any other purpose, we can't use it. So this is a restriction to collect our data. And also some of the issues, challenges we face sometimes in the medical imaging, class imbalance. Class imbalance in the terms like, if suppose we have two different class. So I can give you examples. Suppose one class belongs to the tumor, means suppose it's a non-cancer tumor, another is a cancer tumor. Okay, so non-cancer tumor could be very common, because some people, okay, comes and they have some of the symptoms, they come, okay, they diagnose, so it's not a cancer actually. So in a sense, in 100, we could find 5 or 10 patient or 2 patient which belongs to the cancer. So there could be an imbalance. So if you're going to use those data set or some kind of those data set, there could be imbalance. We can't use, and we need to use apply some of the technique how we could balance those of the data during the training of the models. And also there's some issues in the black spot, because this issue is very common in a deep learning, because once we trained our model, we made our algorithm, but we don't know how the model is learning, as I shown the explainability of the model. So this is the like current scenario in the research community. People want to explore what is the features is going to learn from this model, what are the important features. Maybe these features could be useful for the doctors, for the radiologists, for the clinician. It's very helpful for them. And also in the last, even if you get the data, but if you don't have information, because we are not the radiologists, we are not the doctors, but if you don't have a label information from the doctors, that this data is no mean for us in some cases. So we need to be get this data should be labeled, means we know, okay, this image belongs to the tumor, or this image belongs to some areas, some of the abnormality, we should know from the doctors. So we need it. And in the resources availability, so if someone wants to go through wants to build his or her career, or want to deploy some of the ideas, we have some of the resources available in the open research community. Like there's some toolings I provided here for the medical imaging data, and it covers the different modalities like ultrasound, X-ray, histopathological images, and some various different imaging modalities. Some of the we have ground truth available. And also we have some high computational resources available, as I mentioned. Now we have like a Google Colab, Amazon Web Services, Google Cloud. And also nowadays people use Python programming language. So we have the like big community. If we're struggling with some issues or some question we have, we can directly discuss on the open forum. We can like we can get answer from them, some of the people, those who are very active. And also we don't need to start from scratch. So we already have some very famous deep learning libraries, means we don't need to write all the functions from the scratch. We can just call those functions and we can just build our model. So if those libraries are PyTorch, TensorFlow, some of the libraries from Facebook, some of the from the Google. So those are some libraries is available. So people used to. So the opportunities, if you talk about what are the opportunities, because we have learned, we have seen is like different kind of images, what kind of the challenges we see, but there's some opportunities as well. How we could how we could those of the information, those of the like the informative information that could be useful to build a career and to solve some of the medical problem, because in the medical we have a wide range of problem because it's not solved. So that could be interesting if you're going to make our career for this domain and try to concentrate on some of the specific problem or maybe some different problem time to time. That would be very interesting, and deep learning could be deployed there. And also in our next 15-20 years, we will see like as technology is growing. So most of the things we are trying to translate with using the AI deep learning models. So the thing is that we want to get system automated, where the you can say the manual uh, you can say the computation, it should be less actually, and we want to get optimized, means to increase the performance of the model. And also if anyone wants to be interested, if has a very like a vast interest and is want to make the career, if after getting some good knowledge can build their own AI company. Because what you need to set up your algorithm, and you need to verify, and if it's working well, you can build your own AI company, because you are aware how to do it. Because this is the key point. If you know how to make the algorithm, how you can play with it, and how you just explore this, and how you could solve some real problems, is a very good chance to build AI company as well. And also if you want to move into a job part, there's some other like option as we are going to approach of, suppose we are in BTech and we're going to approach like a master in MTech, or want to make a career in research. There will be good chances to get after that the job is a data scientist or AI engineer, and that's give you like a very like a huge amount kind of knowledge, and also the experience as well. Thank you very much for your attention. If you have any question.
Thank you so much, sir, for such a motivational talk.
Sorry to interrupt. Yeah,
Good
yes, sir. I have
afternoon.
a question, sir. Hello.
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 Uh,
Yeah,
Yes,
you
sure.
sir, can I,
Mhm.
sir, can I ask? You told us about all this, like the imaging and all this related to medical sciences and stuff. So
Yep.
when a person has a stroke, right? A patient has a stroke, or
Yep.
if he doesn't have a sign of a stroke, how can it detect? How can computing or a technology detect that that patient has a sign of a stroke?
Yeah, actually depend upon if is doctor is suggesting like stroke could be the like is going through the imaging modality. So if we're going through the imaging modality like for the brain is stroke, if we're going to take, so it's like for the brain is going to take care about the MRI is very common. So if there is some symptoms, some of the like tissues or some of the things is coming to the that area which is doctor can identify. So if we could those visual features we could feed as a to the network to extract those of the features we could feed to the network, and we train our model, that would be helpful to next in the for the next testing images, that would be helpful to identify those other stroke regions there.
Sir, so if a person doesn't have a tumor, like for example, if a person doesn't have any visual keys of tumor or any damage to the tissue, does he still have a chances of any stroke? Any
No,
chance?
actually, yeah, actually for this, like if the person has no symptoms, no other things, so means is like what normally what we're doing in our deep learning, we are feeding like a different kind of information as an input. Is up to us what kind of the objective we want to look for. Suppose we want to look for the patient has a like a stroke patient or is not. So if we want to give those different kind of images, means the patient has in normal stage or even if the patient has a stroke, we took a imaging from that and we feeding both kind of information together. So once we have new patient came up, even this patient has a stroke or not, model would be able to classify.
Oh, okay, then. Thank you.
Thank you so much, sir, for such a motivational talk. It was pleasing to hear such words from you today. Good afternoon, everyone. I'm Shambhavi, second year electrical engineering student, BBDITM Lucknow. Now, I would like to ask the participants if they have any questions on this talk, please switch on your microphone or leave a question in the comment box section, as per your convenience.
Okay, thank you. Good afternoon, sir. Myself, Singh. I have some sorts of questions regarding the data collections and basically how to create the model. Like we have
Mhm.
discussed about the machine learning, then we have talked about the deep learning, then we have like medical imagery and the CAD tools, and the most
Yep.
important thing, the reason of interest of that, like ROI. So, sir,
Yep.
how to collect those data and how to implement that data into the the websites and how to create that type of API link so that our models can work and finally in the mobile product like Android app or something like this.
Mhm. Yeah, actually for this, like as I can give you example for us, like for the breast cancer project, or even if you can count any other project, yeah, for the data collection is very important. For the data collection means we want to be very precise when we are collecting our data, because data is a plays a very key role because everything is dependent upon the data. So some of the cases, if we have some, because some of the project could be is combined with the clinician, with the hospital, if his project would be big from the ministry or some other part or from other research collaborator. So we are collecting a data from the hospitals directly from the consent of the patient, and those data we are trying to get labeled from the doctors, because we are not the doctors. So the doctor can help us to build this data set actually, because what are the objectives we want to look for. So those data set should be labeled from the doctors. And once we have a data labeled, so that those information is depend upon the task we want to target. Suppose we want to classify some of the disease abnormality, so we want to ask the doctors, okay, you have 100 images, we can, okay, doctor have 100 images, and we ask the doctor, okay, you have 100 images, give me the labels, which image belongs to which class. So we have the labels from the doctors. So this is we call supervised learning, and we need to be confirmed from the doctors, because without doctors' confirmation, it's very difficult to identify from us. We can't make it any tools, and we cannot make any like a confident score based on this. And for feeding a data, when we, as you ask for the feeding a data, when you are feeding, we are applying some kind of pre-processing technique, some of the normalization technique in imaging point of view, and also there's some other technique in a deep learning to get a data balance, and also in the prediction how many classes. So there's some other factors. It's like a vast area, and there's some of the constants should be the measure.
Thank you so much, sir.
Thanks a lot.
Thank you, sir.
Good afternoon, sir.
Good
This
afternoon.
is Sakshi. Sir, actually, this topic was very much beneficial for us. We are final year students. So, one question I wanted to ask that is this beneficial for some of the COVID topics, because we are planning for some of the projects regarding COVID?
Yeah, this is helpful because nowadays is like now vaccine is coming, but for the early, if you could like if you have a public data set available, some of the data set should be from IEEE. I remember is available on their GitHub page. Is linked to the IEEE name. I don't exactly remember, and also some of the data from the city. So that could be interesting to explore. Maybe in the future, if you're trying to find out some of the pandemic is coming. Yeah, we are not be make a trade. Yeah, so if we have some kind of those kind of data and we already experience, and we could find some of the key points, what's happening and what are the changes. So I can give you one very good examples. Like here is that. Suppose if we just suppose this is a COVID patient. Yeah, and for the COVID patient get a scan in a one time when it came to the first time, and after that this patient got treated well and it comes to the next time, suppose after 1 month, and you again scan his or her lung. Yeah, and you want to see the changes. What are the changes happened in between, like the first imaging when you took in the first before 1 month, and after 2, and after maybe 3 months you want to get tracked. And this research is going actually for the what is the effect after the COVID treatment. Some of the patient is feeling some of the difficulties in the different organs. So you want to track, you want to get predictive model. You can get some of the prediction model, like you could make what will be the prediction after 1 month or after 6 months, after 1 year, how this patient will behave on the treatment. There's some lots of opportunities you could explore on this part.
Okay, thank you, sir.
Thanks a lot.
Good afternoon, sir. Sir, I'm
Yeah.
Shambhavi, a second year student. As a second year student, I would like to ask that since COVID-19 is a very recent topic, then what project topics can we pick from this?
Yeah, actually, in the medical domain, you can find lots of project, and there's lots of options people could explore. Even this is a very limited. I just as constant with the time. There's a limited one, but another thing is that I would like to mention. There's a vast area. You could work on the MRI for the brain. You could work on the other abdomen. You could work on the liver, work on the kidney. You could work on the gallbladder, because in the gallbladder there's a nice topic actually in Uttar Pradesh. Actually, lots of the patient who diagnose cancer, which is goes to the abdomen, which is belongs to the gallbladder. And the thing is that there's very less research which happened with the gallbladder, finding early diagnosis of the gallbladder cancer. And the reason is that when patient diagnosed, and the point is that there's like is at least like very less time for the patient actually is very late diagnosed actually. So idea is that if you could make some of the tools, some of the models, some of the like CAD system for the doctors, even for the gallbladder, or could be the liver fibrosis staging, or could be the kidney problem. Yeah, so there is a vast area. The thing is that you need to consider about the data, where you can collect your data.
Okay, thank you, sir.
Thank
Now I
you
would
so much,
like to
sir.
invite.
Shambhavi,
Yes, sir.
thank you so much, Vivek, sir. I have a question, sir.
Yeah,
Sir,
sure.
our final year students and second year, third year students all have joined, and they are looking very interested in this topic. So, sir, if final year students are going to start their project in all these topics, you have mentioned 3 or 4 projects here. So, how
Yeah.
they will start to do work in these
Yeah.
projects?
Yeah, this is a very nice question you put up. Like the first thing is that if the like student has no background about the machine learning and the deep learning, if I assume, so it would be nice to start with the fundamental concept about the some concept of machine learning. There's some open resources available on the Google. They can find some of the open resources, some of the courses available, free of cost, open resources available, and some lecture on YouTube. They can get just some of the ideas and how the deep learning work, machine learning and deep learning both. But before this, I would be more prefer if they are going to use the image as a for the perspective to work on the images. I would prefer also to get some knowledge about the computer vision and image processing, some fundamental knowledge about the image processing. And also the main thing, because they want to deploy their model as well, they want to use some of the algorithm, how they can deploy. So means they have, if they prefer, they can go for the Python, they can use those languages, and they can build their model after that once they get some of the knowledge from machine learning, deep learning, because those knowledge is very important, because it's going to use everywhere. So if the fundamental information is clear, they can be they can feel very easy when they are developing their model, and they can get their own ideas actually.
Thank you so much, sir. And sir, how they will make model from online or by using any software, sir? Please.
No.
Yes, sir.
Yeah, actually for this, I just want to make there's some of the open resources available on the GitHub, and there's some data for the experiment data. They have some data also put up. So the only thing is that if you just if the student can get some knowledge about, once they get knowledge about, they spend some week to get knowledge about machine learning, deep learning, and what are the component of deep learning. Yeah, some of the, what is a convolution, what is the max pooling operation, or what is some other functionality of the deep learning. If they can get knowledge, so they can directly approach some of the open resources GitHub code, and they already have a code working in a PyTorch library in the Python, and they have some data. They can find it, and they just run and just try to understand those codes. That they don't need to make anything from scratch in the beginning. And once they understand what is the functionality of that line, and how this code is flowing, so after that they can understand, okay, they got idea practically, and how this model is working. After that, they will be able, I believe they will be able to build their own model after some time.
Thank you so much, sir. Thank you so much.
Thanks a lot.
Yeah, I also have a question as a student, more of a student, and I think Dr. Vivek Kumar Singh is the most appropriate person to answer on that.
Yeah, sure.
I'm recalling my experience more than 1.5 decade back. I was in IIT Delhi interacting with my supervisor, and he was Professor Madhasu Mandu. And he was the, of course, from electrical engineering department professor. And at the same time, he was heading the biometric research laboratory, which was the best laboratories of the whole North India at that point of time. So, and I really wondered that, he's an electrical professor. I'm talking about that time. And all the students, they were almost from the electrical engineering, most of them, I would say, 80 to 80%, and 20% from computer science also. But majority of the work was being done by all MTech thesis and PhD scholars also. They were doing in medical imaging. And as I said, the majority of the students, I would say more than 3/4, they were exclusively from electrical engineering. Then I realized that, initially, I think this might be the case with some of our students. Most of them are really sensitive about the interdisciplinary approach. But since you also, Dr. Vivek Kumar Singh, you also hail from electronics engineering background. And we see that when we talk about medical engineering, it has been a prime interest for electrical and electronics engineering. And in fact, majority of the work all over the world is coming out from these disciplines in medical imaging. So, and since you have undergone this transformation, gradual transformation, what is your take on about the interdisciplinary approach? What is your take about false myth or maybe initial confusion on part of the students regarding whether it relates to our core or not? Because I realized that most of the students later on they worked in the core itself, but because of medical imaging, they were able to really do extraordinary work, and they were able to prove their excellence, and they in follow-up worked in the core part only, in power system and all that. So what is your take on this interdisciplinary nature, which has already taken off, and what, since you yourself have been given, or you have yourself have been a case of inspirational transformation. So I would like you also to touch upon, so that all students are able to see that there is no boundary, exactly definite boundary, and it's And in electrical engineering, guys are doing exceptionally well in these areas, along with the electronics engineering, no doubt. So what is your impression? What is your interpretation of this?
Yeah,
Simply
sure.
said,
Yeah, thanks a lot for putting this question. Actually, yeah, this question is very interesting for like most of them. Like for me, as I comes from the electronic communication background, and my master was in signal processing, and this PhD when I have finished, and even the presently what I'm working, which is on the image processing. So these are the two different domains, working on signals and working on the imaging, and also not coming from the computer science background. So means if we want to develop, we want to develop our knowledge, we want to develop our interests, is depend upon us. Like for me, when I started my career on image processing in biomedical imaging, it was that time I started my things like it was very interesting. Actually, in medical imaging, very interesting. For it's truly when you started work, you will feel real things, and if thing is related to the body organ, is like always like interesting. Okay, it's always a curiosity how we can get and how we could make, and it's like you could see in the real time if you are in a good place and you can translate it in those algorithms. That would be super interesting. You can feel those the thing what you have been developed. And the thing is that if like for me when I started, I was started with the like self-study with the image processing, just took some of the courses from the internet and developed my interest in image processing, and also get familiar, try to spend 1 or 2 months with the medical imaging part, or like some part of terminology which doctor use, and what are the like how they use the data, and what is the how this data is important in terms of the statistical analysis, building some of the models, what is the significance. So is that is not comes from the only thing is that we just need to develop our interest, as I believe for me. And if you have interest, that would be like once you start you will feel very easy, and it's like give you the like motivation to continue like your path. And this is like for me it's like the same thing what I have been made when I started with the image processing and biomedical. So I started with the very one project as you seen in the breast cancer, and it was a Spanish ministry project I was started. But after that I realized after 6 months, oh maybe this of the application what I'm developing, that could be helpful for some different application. And after that I try to translate my models what I've been developed with different images, different kind of modality, and it's give me some interest, and also make me like it's kind of you can play with your models with your own ideas with the different problem, real challenges problem. And once you could solve those problems, you will feel very relaxed and you will feel very confident with your skills. And that's the thing like is like give me motivation to continue my research career into a medical domain. Even presently I'm working on the medical domain, medical imaging, and I would like to continue in the same domain. So if anyone is coming from the different background, electrical or electronics, even from the mechanical, I have seen lots of candidates when I was in Spain. They were from a different background, and they make their career in a like especially called medical imaging or the computer vision. So it's depend upon the student how they are developing their interests, how they want to build their career. They want to go for the academic, they want to go for research, or they want to choose the industry part. So it's up to them. But the I can just give my experience, like to be very honest, this field is very beautiful. If someone want to come and join the field and want to explore their interest, that would be super interesting.
thank you, sir.
Thanks a lot.
Thank you so much, sir. Vivek, sir, I have one question again.
Yeah,
Uh,
sure.
you are the alumni of Gautam Buddha Technical University and one of the reputed alumni. So,
Yeah.
sir, our all final year students are joined. Sir, what message would you like to give to our students? Because you have started your journey from here, and now you are in the Harvard University and doing excellent research work. So, sir, what message would you like to give to our students, sir? You are most
Yeah,
welcome, sir.
yeah, exactly. The motivation could be like, don't think about it where you are learning and like which place you are. The thing is that what you learn from your professors or from your faculties, and how you're developing your interests. So this is the most important thing. And because don't think, just don't be a narrow. If you are living in a small cities, and even we are, you can't approach the like another country, or you cannot go. You have to be think high always. And even if you're thinking high and your approach is positive, and you're honest with the work, that I think is like always it will give you some feedback, very nice feedback. And as for me, as I also come from the Gautam Buddha University, I was alumni. I passed in 2011. So at that time when I was I was in MTech, I decided to just to explore more my field, and also to target achieve some of the bigger objective. and that's gave me motivation. So if you have like a plan, bigger objective, and you are clear with the objective and honest with your work, I believe if you are going to target in all around the world, any universities, any research group, any of the industry, that is, you will feel, oh, okay, it's like a small, yeah, what we learn. Because most what I feel, the information what we got from our faculties during the bachelor and the master, that is going to always help you, because this is a fundamental knowledge. It's going to help you always. So it's like, for me, if someone is in the undergraduate or in the master level, so I just recommend just to take those courses, those subject information as much you can, those knowledge, and also try to correlate. Because what I feel in the outside, because in the of the universities, what at that time I was, the practical knowledge was less, and the subjective was high. But as we coming from outside of the India, and what we realized, that my personal experience, that is all the thing was on practical. There was subject was zero actually, and the subject was, this means your knowledge what you have gained. They assume you already have your knowledge you build up during your master or the bachelor levels, and they want to get experimented directly. So you will not get a chance, very less chance to get explore those subject information. So means, if you can correlate what you're learning present days of the topic with the practical application, that will help you always, and that will give you interesting thing. You can deploy your own ideas in futures. Means, if you're learning some of the topics, suppose someone come from the electric background, some satellite communication, or the wireless communication, or the some of the chapters coming from the different domains, like different subjects. So but if you could find some of the topic, and you could correlate, go to the YouTube channel and find out, okay, what is a practical application for this, then you don't need to even learn even, and you can build your interest directly. This is like, for me, is personal experience. So I think that would be very interesting for the student, and they can use it.
Thank you so much, sir. Thank you so much, sir. And now, Shambhavi, it is over to you. Please proceed further.
Thank you so much, sir. Now I would like to invite our branch advisor, Dr. Khadim Moin Siddiqui, sir, to give vote of thanks for today's session.
Thank you, Shambhavi. Am I audible, Shambhavi?
Yes, sir.
Okay, very good. A very good afternoon, Honorable Speaker Dr. Vivek Kumar Singh, Postdoctoral Fellow, Harvard University, esteemed Director BBDITM Professor Dr. Bhavesh Kumar Chauhan, respected HOD EE&EN Professor Rafiq Ahmad, faculty participants, student participants, and volunteers. It's my proud privilege to propose vote of thanks on the behalf of Babu Banarsi Das Institute of Technology and Management, Lucknow, in the event My Story Passion into Action, inauguration session of WIE BBDITM Affinity Group and Distinguished Lecture Series. As a part of the Distinguished Lecture Series, today we have participated in the expert lecture on New Height for AI in Medical Imaging, Challenges and Opportunities. First of all, my profuse gratitude and sincere thanks to today's Honorable Speaker, Dr. Vivek Kumar Singh, Postdoctoral Fellow, Harvard University, USA, for accepting our invitation with so much willingness for nurturing to young engineers and us, and also shared his valuable experience on the very recent topic of the research, that is New Height for AI in Medical Imaging, Challenges and Opportunities. Honorable Sir, it is a very recent topic of the research, and we have learned a lot through this splendid lecture. Sir, from this platform, definitely I will express that you are one of the wonderful young scientists and researcher of your field, and actively participating in the benefits of humanity. Further, I want to inform all participants happily that our honorable speaker was giving presentation from morning time around 1 a.m. and right now it is around 2 a.m. It reflects that the enormous dedication, encouragement, and also given us great motivation and inspiration to follow his paths. And also, honorable sir is going to become one of the role model for our students. Honorable sir, we have received a lot of inspiration from you, and hopefully in the upcoming programs you will see more effective process during the preparation of the program from our side. Again, thank you so much, honorable sir. I take this opportunity to express our sincere thanks and deep gratitude to Professor Dr. Bhavesh Kumar Chauhan, Honorable Director BBD ITM Lucknow, for his esteemed presence amongst us Honorable Director, sir, without your constructive mentorship and guidance, we are unable to organize this kind of program in the effective way. Thank you so much, sir. Further, I would like to thank to respected HOD Professor Rafiq Ahmed for his able leadership, continuous and moral support. Now, thanks to all participants, student participants, volunteers for joining us and making the event successful. At the last, thanks IEEE BBDITM Student Branch, student members, especially Mr. Shrikant Singh, Mr. Marut Nandan Tripathi, Ms. Shakshi Priyam, Mr. Shrek Khanna, Mr. Abdullah Ahmad, all women in engineering team and all IEEE student members, especially anchors Mr. Sayyed and Ms. Rambhavi, for your diligence to conduct today's program in the effective way. Again, thank you so much all.
Thank you so much, sir. Now I would like to request the participants. Feedback form and the quiz link has been circulated in the chat section. Kindly fill it. Please take a look at our upcoming events. Now I request our Honorable Director, sir, to declare the session officially closed.
Yeah, thank you, anchor of the program. Before I declare the event over, I offer a deep sense of gratitude to Dr. Vivek Kumar Singh, who is associated with the MGM Center for Research in Ultrasound and Translation. And it was really a marvelous session, a splendid session, and both as a professional as well as on a personal behalf, I extend a thank as well as a sense of gratitude towards you, and I'm sure this relationship now onwards, like in past, it was on a personal note and in professional note also, we will keep exchanging this warmth. So it's a great service that you are doing to community. It really makes us feel proud as well as feel inspired. So thank you very much for your encouragement, for your mentorship to the BBDITM branch and in particular to the WIE Affinity Group. And congratulations to all the IEEE members and office bearers, volunteers of this program, organizer of this program, for having arranged this event in the right spirit. Thank you very much. I think we can close with the event with the permission of the honorable speakers also. Thank you very much.
Thanks a lot. Thanks a lot for everyone here.